Hello and welcome back. This time we're working with a quadratic of some kind, a parabola. Let's have a read. This says find the equation of the parabola shown. Okay, so if we want to get this equation, let's think of what form we could put it in. So we could do y equals ax squared plus bx plus c, but this doesn't really help us to graph anything. Something that might help us is y equals a, open bracket, x minus h, close bracket, squared, plus k. Now this one here, you may use different letters besides h and k. You may use a plus in the brackets, but that's all right. This is called the turning point form. Now, I've shown it to TP just because I'm lazy. Now, if we look at this graph, we've got some critical features we can look at. So we've got this y-intercept up here. We've got the y int, and that's at 0, 4. Remember, any intercept is going to be a coordinate, an x and a y value. So the y-intercept is not just 4, it'll be 0, 4. We've got some x-intercepts, but if you look carefully on the graph, they don't really cross at any particular point. It appears to be 3.6 maybe, but it's not exactly on that blue marker, so those are a bit unreliable. The only other given piece of information is the minimum. So we've got another coordinate, the minimum, and that's 2, -8. And that happens to also be our turning point, which is very, very handy. So that means we can fill in our turning point form. Now let me just explain the turning point form a little bit. In here, we've got a h and a k. So the turning point is going to be just h, k. That's it. So if we sub in 2 for h and -8 for k, we'll have our quadratic, our parabola, in some equation. So let's do that now. So we'll have y equals a, open bracket, x minus 2, close bracket, squared, minus 8. Nice. Now, we're not quite done. There's a problem here. We've got this a value. Now, the a value is an unknown. If we had another coordinate, an x and a y value, besides the turning point, we could find our a value. Luckily, we've got our y-intercept. It's at 0, 4. So if we sub in x is 0 and the y is 4, we should be able to work out our a value. So let's do that now. 4 equals a, open bracket, 0 minus 2, close bracket, squared, minus 8. Let's plus 8 to both sides to go to that -8. So 12 equals a, open bracket, -2 squared. So -2 squared, that'll just give us 4. So 12 equals 4a. We've got an a value of 3. So let's write that down. We've got y equals 3, open bracket, x minus 2, close bracket, squared, minus 8. Now you might be thinking, well, we subbed in x and y. Why have you brought them back? If we don't have an x and y here, we won't have an equation for a parabola. We'll just have something that says 4 equals 4. So the only unknowns that we needed to solve for turning point form were a, h, and k. And when you're stating your equation, don't forget you need those x's and y's in there. Otherwise, you won't have an equation that gives you a graph. You'll just have something that says 3 equals 3 or 2 equals 2 or something like that. So now we've answered 15a, the equation of the parabola. Next up, B, state the dilation and translation transformations that have been applied to y equals x squared to achieve this parabola. So part B, we've got a dilation. Now the dilation is whether it gets narrower or wider. So it's become narrower. And by 3. A is the dilation factor. If your A value is greater than 1, it's become narrower. If it is between 0 and 1, it will become wider. Next up, it's been translated to the right 2, and it's been put down 8. Now these relate to the turning point. Y equals x squared looks something like this. But of course the turning point is at 0, 0 for y equals x squared. So this has been shifted across 2. Let's see if I can get a finer pen. So it's been shifted across 2 and then down 8 for our new equation. And it's much narrower than what it was. And down here, we've got that turning point to -8. So B, the dilations and translations that have been applied to y equals x squared to achieve this parabola, it's become narrower by 3. Oh, let's change our thickness back. We've got it going to the right 2, translated to the right 2 in the positive x direction, and translated down 8. Now we've got question C. This graph is reflected in the x-axis. State the equation of the reflected graph. Okay, that one's not too bad at all. So our A value was 3. If it's getting reflected vertically in the x-axis, that would mean our A value would now have to be -3. So normally a parabola will be a smiley face with a minimum if the A value is positive. But if it's getting flipped or reflected, that would mean it would have a maximum, and also it would be a frowny face. Now, question D asks us to sketch, so we'll have a look at that when we get to it. So our A value has changed from a +3 to a -3. The X value, if we flip it, it was here at 2, -8. If we flip it, it will go directly up. So our X value will remain the same. Our H value for the turning point is still 2. But our K value, that will change. So it was -8, but it's been reflected in the x-axis. So it'll pop up to +8. So now we've got a new equation, very similar to our previous one. Let's sub in our values and see what it looks like. Y equals -3, open bracket, x -2, close bracket, squared, plus 8. There we go. Now for D, sketch the graph of the reflected parabola. So we're sketching this new graph here. So let's draw a perfect set of axes. Beautiful, beautiful. 1, 2, let's say it's 2, 4. Sorry, -2, -4, 2, 4, 6, 8. Fantastic. So our turning point is at 2, +8. And before, we did have a y-intercept at 0, 4. Our new y-intercept for our reflected parabola will be at 0, -4. Now, when you're asked to sketch something, you may not get it perfect, and that's okay, as long as you've got a kind of general idea of what it looks like. Oh, yep, yep, that's fantastic. That is probably the best parabola I've drawn in my life. Luckily, it was recorded. Alrighty, that's it. We've done the equation of the parabola shown. That's just up here. Here's our question A done. B, stating the dilations and translations. So it got narrowed by 3. That's our A value. It was translated to the right to 2, and it was translated down 8. C, the graph is reflected in the x-axis. State the equation of the reflected graph. So that would mean we've got a frowny face here. It's been made narrower. It's been reflected, so our a value is now negative. The x value of the turning point doesn't change because it's just gone straight up from its previous position. But the negative 8 at the end, the y value of the turning point has now become positive 8. And that's the new equation of the reflected graph. Then for D, our graph, as long as you've got some key features that are needed. So let's see here, they wrote local minimum. Maybe we should write the same. Local max, and the coordinate of that is just 2, 8. One thing that I'd really like to see is everyone to include the origin, arrows on your axes, and label them as x or y or whatever variables you're using. Alrighty, that's it for today. Thanks for joining me, and I'll see you next time.